2 moles of monoatomic gas change its state from D to A, as shown in the figure below. Given that P over T equal to 1, what is the difference in the total translational kinetic energy of the gas between D and A? The graph given in the figures is P versus T, where the P is the pressure in Pascal and the T is the temperature in Kelvin. Note that the state A, the pressure is P and the temperature is T. And the initial state for the state D, the pressure is 4P, but the temperature of the state D is not given. It's not given in the graph. But according to the questions, the P over T is equal to 1. And we notice that this line that connecting the state D and A is passing through the origin. That means the gradients of the line is equal to 1. Therefore, for the state A, when the pressure is P, the temperature is T, due to the gradient is equal to 1, then we know that when the pressure is 4P for the state D, the corresponding temperature for the state D should be 4P. So now we have these two coordinates for the two states. For the A, the coordinate is the TP, and for the state D, the coordinate is 4T and 4P. Now we try to find out what is the total translational kinetic energy of the gas. Since this is the monoatomic gas, based on the kinetic theory of gas, we know that the average translational kinetic energy for the monoatomic gas depends on the temperature T, which is equal to 3 over 2 kT. But what we want to find is not the average translational kinetic energy per molecule. We want to find is the total translational kinetic energy of the gas. Therefore, to find the total translational kinetic energy, we multiply this average quantity with the total numbers of the molecule of the gas. So if the left-hand side of the equality sign we multiply with n, then we must multiply also the n for the things at the equation at the right-hand side of the equality sign. So we have the n at the left and n at the right. N, capital N, is the total number of the molecule. Now we change the symbols at the left of the equality sign as a EK without the bar. So this one indicates the total translational kinetic energy. The E with the bar on top refer to the average translational kinetic energy per molecule. This one is the total quantity. So at the right hand side, the NKT, now we change it to nRT. The reason is because the capital N is not, the information of capital N is not given by the questions. But of course, since we know that the number of mole is 2 for the gas that we consider, we can also find the N if we want. But now we try to express this N in terms of N so that we can directly substitute the number of mole by 2. Okay, so to change this capital N into the small n, we apply the equations of the state, because we know the equation of state for the ideal gas, it is PV equal to NKT. Another form is the PV equal to nRT. So that means if you look at the right hand side of the equality sign for these two equations, that means NKT can be substituted by this nRT, replaced by this nRT. That's why we have this nRT here. R is the gas constant and the K is the Boltzmann constant. Both are the constant value. So based on this result that we obtained, now we can evaluate what is the total translational kinetic energy change when the state of the gas change from D to A. So we use this final state, total translational kinetic energy at the final state, minus the total kinetic energy at the initial state. So this is for A, this is for D. So based on this general formula, we know that it is equal to 3 over 2 nR multiplied with TA minus TD. TA is the temperature of the gas at the state A. This is the temperature at the state D. But based on the coordinates for the state A and D in the PT diagram, we know that this TA is a T and this TD is the 4T. Therefore, now we have these expressions with the n equal to 2, 2 more given in the equations. Now, because T minus 4T will give us negative 3T, these 2 and 2 cancel out, so 3 multiplied with negative 3 will get negative 9 RT. So this is the answer. This is the difference in the total kinetic energy of the gas between the state D and the state A. But we need to know what is the meanings of the negative sign in the answer that we obtain. This negative sign, when the state changes from D to A, the negative sign indicates that the total translational kinetic energy is reducing. Why it is reducing? Why there is a negative sign here? It is simply because if you look at this formula for the average translational kinetic energy of the gas, we know that this kinetic energy depends on the temperature T. Same thing happens for the total translational kinetic energy. It depends on T. So from the state D change to state A, the temperature is dropped from the 4T to the T. Therefore, the total translational kinetic energy of the gas would also reduce. That's why we have this negative sign. If we take the final quantity of the EK, or total translational kinetic energy, minus the EK for the initial state, which is a state D, we will get the negative sign here.